Hi everyone. Am I audible?
Yes, ma'am. Good evening, ma'am.
Yes, ma'am, you are audible.
All right. So shall we go ahead and start the session? Okay. Just a second. Okay, is my voice better now? Okay. Can one of you tell me? Okay, is my voice better now? Okay. Can one of you tell me?
Ma'am, we can start now. Like we are live right now.
All right. Just give me 1 second. So I need that YouTube link. Just a second, and we'll start in 1 minute.
Ma'am, your voice is breaking.
Is it better now? So I'm actually using a fast internet connection. It shouldn't break. I'm actually using fiber net. How much is it breaking? Is it a whole lot?
No, ma'am. Now it's fine. Now it's fine.
It's fine. Okay. Oh, thank you. Thank you, Krishna. So I don't see many questions on our YouTube live posting. So if I can ask you, are some of you the participants in the course? Are you taking up the course?
Ma'am, pardon, what did you ask?
Yes, I'm asking that we are having 10 participants, right? So one is from IT Madras side, and I think Krishna is a TA for the course. About others of you, so I'm asking, have you taken up this course?
Yes, ma'am, taken this course and applied for the exam as well.
All right, that's great. So I think that we can chat within us. So I'm still waiting for some questions to appear on our live YouTube chat. So we'll take those questions as and when they come up. So if any of you have any queries, we can proceed with that. So, brief introduction about myself. I think I haven't introduced me. Yeah, so I would say let us discuss more technical queries, AT. So whether there will be a programming exam or not, I think those questions we can ask on discussion forum, right? And TA will get back to you. So a brief introduction about myself. I'm a co-instructor of this course. So I have done my PhD in social network analysis and complex networks from IIT Roper. And after that, I had two brief postdocs, one at IT Madras, one at IT Delhi. So again, I was working on some applied graph theory based problems there. And then for next 1 year, I've been an assistant professor at Triple IT Harvard, and currently I'm teaching at Mahindra University, Hyderabad. So I thought it would be nice to introduce myself. So any questions? So we had one question in the form that was shared that was regarding the scope of this course. So most of this course, I think we recorded this course back in 2018. So this course gives you a very good basic foundation on what is being done in social networks and complex networks as such. But then I would like to highlight that there have been quite a good advancements in the literature from like that time till now. So as an example, there is something called graph neural networks, which is picking up. And once one has done a course in machine learning and social network, that is something which you should really look at. It's a hot topic these days. So these graphs, they allow you to do analysis on a kind of data which is not tabular. So if you look at any of the traditional machine learning algorithms and the data they are associated with, so most of those are tabular data, right? You look at some columns and predict some other column. So in that sense, graphs are very different. So your traditional machine learning algorithms will not work for graphs because it's completely relational data, a whole new different kind of a data. So that's why people have come up with something called graph neural networks. And if you have heard of, there is something called protein folding problem. Does anyone has an idea about what that is? Have you heard of it has name, just a second. Yes, so have you heard of something called AlphaFold? So it was quite a famous discovery, I think back in 2020 or 2021. You see, most of the concepts which you are studying in this course, social networks, you can apply them to any setting where you see some kind of a graph. So basically, there are certain nodes and they are connected with edges. It need not essentially be a social network between people. There are a whole lot of other networks which you'll find. So as an example, network of neurons in brain. You might have studied food chain, right, when we were kids. So I would say a more scaled version of food chain. We call it ecological networks, where again you have animals or species as nodes, and if two species are connected, right, they sort of feed on each other, or one of them feed on another. You can create a graph. And so when I was at IT Delhi, I was studying something which is called the corporate network. So there are people who sit on the board of the same company. So we put an edge between these people. So this is a network of eminent directors of different companies in India and maybe even abroad. So one can actually analyze such a network to look at which are the most prominent CEOs in the Indian corporate network and even which are the most prominent companies. So an analysis like that will help you deal with the problems of recession, which is that company which is false will create the largest damage to network. And then I've been talking about protein folding networks. So protein networks are again studied a whole lot. And this actually helps the research ongoing for cancer. It has been shown that how these proteins in our body, they fold up. So there's basically a sequence of amino acids, and this sequence can in the future fold like anything. And the way in which it folds, that sort of decides, and that's a deciding factor for whether you'll suffer from a disease or not. So it has been, so I haven't worked in this particular direction, but yes, I've heard of it. So this is again a prediction problem. So can you look at a sequence of amino acids and then predict how it's going to fold in future? So previously people were using different machine learning techniques for doing this, but recently, like in 2020, there is something called AlphaFold, which came up, which was based on graph neural networks, which provides one of the most promising solutions in this field. Okay, Monolith has this question. So what are the problems facing researchers in the use of academic social networks? I would say one of the biggest problem is the availability of data. Uh, so although we have some APIs, we can fetch Twitter data, but again, not a whole lot of it. And then most of the data that we get is anonymized. So if you'll see that a whole lot of research in social networks, it is done on artificial networks, some of which are introduced in the code. So as an example, assuming that the network is random or it is scale free, and we have a few anonymized social networks. Previously they were available, but now with strict restrictions on the social media because of the privacy reasons, we get less and less of data. At my time, Facebook was quite popular, so I did some research on the induced subgraph of Facebook, and then Twitter data was also readily available back then, but now getting the data through Twitter API is becoming more and more difficult, and I don't know if someone needs WhatsApp data, whether that is even available or not. So if any of you get WhatsApp data, so also get in touch with me. Different approaches to model the background knowledge of attackers in a database or social network context. Okay, so if I would actually rephrase this problem as, so how can I know that how much vulnerable a particular social network is, right? It's similar to that problem of recession. If there's like a network of companies in the world and one of the companies sort of falls down, so how much impact will it have, right, on the entire network? So an attacker will also want to do that. So if you want to damage a network, which is that particular node that you should attack, there's again a lot of work done in that direction. So I think something like a centrality measure. So one approach is using centrality measure, right? You might already be knowing about a few centrality measures from the course. So one of the ideas which comes to mind is simply the degree of a node. Then I think we have discussed some more centrality measures, betweenness, closeness. So which of these so again, there is a whole lot of research in this direction. So how do you figure out how vulnerable a network is? And you see, again, it also depends on how you are framing the network. I would say a random network is not that vulnerable, but the actual social networks, the way they are framed, right, that scale-free degree distribution, presence of only a few hubs, that actually makes the network vulnerable. But again, what is interesting in these real-world networks is if you look at these few hubs, they are also tightly connected to each other. So look at something which is called a rich club network. So there are a bunch of people, these are mostly highly influential people having very high degree. They are connected to the remaining network and they are also very strongly connected to each other. So I would say these are the people which provide the strength to a network. So I think we have discussed in the last week of the course, something called a core periphery structure. Right? Conceptually, what is the difference between social isolation, loneliness, and lack of social support? I'm not very sure if I can answer this question because I wouldn't say that these are very well-defined jargons in complex networks. So maybe these terms are a part of a research paper and these would be there in the research paper. So as such, these are not, I would say, standard jargons in complex networks so that I could comment about it. If you would ask me something like what's a Google page rank, I can tell you. But about loneliness, social isolation, I'm not very sure. But yes, I can give you some insight into it. Mm, not exactly into social isolation and loneliness, but some kind of research which has been done in this particular direction. So there are a bunch of works. So look at this book called Connected. It has been written by Nicholas Christakis. So Nicholas Christakis is actually a medical doctor and he also works in the field of social networks. So he has done a great deal of research on how do our social networks, they basically promote feelings. Okay, I'll take the network questions one by one. So how do they promote feelings? So if someone is happy, does it make others happy and up to what particular level? So he has shown that if you are depressed, it makes your immediate friends depressed and not just them, your friends' friend. So the idea is if some of your friends' friend is depressed, it's highly likely that you'll also get depressed. If you gain weight, it will lead to your partner gaining weight, which in turn will lead to his or her friends also gaining weight. We have done a whole lot of research in this direction. And in one of the in his interesting work, he actually shows that you can just look at the structure of a network. So assume that there is a network of a classroom and we remove the names of all the people. Basically, I just have the network and I don't know who is who. That's generally how we get the data, right, in that particular form. So can you just look at this network? So I even do not have any attributes of any particular person or any node. And can you get a hint into who is an extrovert here, who is an introvert? Right, so that is what comes in my mind when I look at these words: social isolation, loneliness. So I would relate it to something called clustering coefficient. I guess you'll be aware with that, right? Clustering coefficient. So what fraction of your friends are friends with each other? That gives you a good idea into the trait of a person, right? So we can say that people who are introverts, they again have a lot of different friends, but you won't see those friends to be friends with each other. And although I'm not sure whether I should cite that research here or not, it is sort of unfortunate. In one of his works, Christakis actually figured out that so no one should take it personally. But then he figured out that the people who have actually a low clustering coefficient, they are more prone to committing suicide. And again, this phenomenon, it was more common in teenage girls. So that's the kind of research he does. So connecting the structure of a network to the people and societal effects, depression, happiness, smoking, a whole lot of, I would say, behaviors he studies by looking at the networks. What do you mean by organic relationships? Can you just yes, Nilesh, you have a query. You can type it in the chat window, or you can also unmute yourself and speak. It's fine.
Yes, ma'am. Ma'am, I was saying in social networks, like till this week, whatever we have studied, we can only talk about them in general terms, right? We have Sudarshan sir also did some mathematical calculation, but in the end, we know that there can be exceptions to it, or there can be results out of it. So, is it correct to say that whatever we are doing, these are only hypotheses, not some proved terms?
Uh, So see, exceptions are also always there, right? Even if you are working on some hardcore machine learning algorithm, right? Once in a while, so you also see exceptions there. So a hypothesis is something, right, which happens generally. So when I say it is a hypothesis, it should hold most of the times, right? And I can say that it is correct. So exceptions will always be there in like every or any scientific field.
And then like what is the difference between a connected graph and a complete graph? Because in this week question, in the previous week only, there was a question like after a large number of iterations, what will be the status of the graph? So I mentioned it. It will be a connected graph, but they have also given a reason in the answer that it will be both connected and complete. But ma'am, after a large number of iterations, we can't guarantee that it will be a complete graph, right? We can say it will be a connected one, but
Yeah,
we
with a
can't
very
guarantee it will
high,
be a.
I agree with you. So with a very high probability, you can say it can be complete, but definitely there can be some 0.00001 probability that it's not complete. So I'll take
So,
a look at
ma'am,
that question.
yes, ma'am. So, like in this regards, like what should we go for? Should we select both connected and completed, or should we go for the connected? Because mm, connected will be a correct answer definitely, because after a large number of iterations,
No, I
there
so
is.
here we should go rationally, and we cannot guarantee that it will be complete. So
Yes.
if there's a or there's an option that says that with high probability it will be complete, that's correct. So that's my opinion of it. So we cannot guarantee that it will be complete.
Okay.
And guarantee means
Okay.
with 100% probability it will be complete, and that need not be true.
Yes, ma'am.
Okay, one or two references about the studies on social media based brand communities which have collected data globally. Social media based brand communities. Who asked this question? Can you unmute yourself and speak? So I'll have a better idea of what you are trying to ask. Monojit. Monojit, can you unmute yourself and then talk? So recently I've been doing some work into this field of finding influential people in a social network, right? So that's a part of my research, which sort of appears in the, I would say, last week of the course. And see, again, what I'm telling you are the points which come in my mind by looking at these questions. Okay, it's okay. So if you could sort of tell me, what do you mean by social media based brand community? So are we talking about influential people here? So what kind of work has been done in that direction? So I understand that, see, there are companies which collect data, there are research institutes which collect data globally. There was this paper which came up in 2013, worked on a good amount of Facebook data, but then most of the times the data is not available to public. Once all the research has been done on that data, and there's very less to do, the data is released publicly if you're asking about the data. So it's always good to set up your own platform and collect the data. So as an example, currently here at Mahindra, I'm doing one of the projects with final year students where we are trying to create our own friendship network of students to see how their friendships affect their GPA and is there a correlation between that or not. Specialized, known, geographically bound communities. You have to be some more general, Monojit. It's sort of difficult for me to figure out in what sense are you using these jargons. Can you give me an example of some company like that and then ask this question? Okay, we have a few people on YouTube also. Is my voice feeble? Let me see if I can increase the size. Okay, I think my mic volume is highest, but I'll try to speak louder. I think that will help. Okay, students who are watching us on YouTube, please feel free to post your queries. So take a look at this YouTube playlist. It's called Machine Learning with Graphs. So you'll get a very good idea of what is being happening in the world now, specifically in social networks. Right. So since there is this hype about machine learning and there's like not a whole lot of machine learning algorithms which you can apply on graphs. So there is this emerging field. So how do you do machine learning with graphs? So George Leskovic is, I think he's at Stanford or I don't remember in which university he is. So George Leskovic is one of the most famous researcher in this area. So he's floating this course called machine learning in graphs, and it is like totally free. The entire playlist is available on YouTube. Actually, I'm also going through that, and if any of you is interested, we can also have a discussion on that sometimes. Okay, any other questions with respect to the course? I would say technical questions.
Ma'am,
Yes, go on.
ma'am, while we are going for like the coding part, like as we know, the network X is a very vast module, right? So
I
like
I'm very
like how to code it properly, like it happens with me that like as of now there were not much coding questions in the MCQ, so that was not a problem for me. Like theoretical concepts, it might happen that theoretically I am sound with it. Coding, I know that it by referring it, I can code it, but how to like code it for a whole new graph, for a whole new data set on your own without like getting stuck anywhere much, like a
so
basic code.
okay. See, Nilesh, so my take on this is if you want to code, so first of all, the problem should be very clear to you, right? And see, it's less about the code, it's more about the algorithm that you are going to follow, right? So I don't see any difficulty in coding. So as an example, let's say I have a graph and let's say, what example can I use here? Just let me think. Um, can you give me an example of like some problem here? Thank you, Abhilakshya, for
Ma'am, we
posting.
can take the last week's problem, the random walk algorithm.
Okay, the random walk algorithm, right? Yes, that's a good example. So let's say I want to code this Google page rank problem, right? Completely on my own. So one idea is you want to find page rank, you figure out the network its function and you use it. But let's say I want to create my own random walker on this graph and then I want to keep a track of which node I'm visiting, how many times, right? Then you see more than writing the code, it converts into a problem of algorithm and data structure. So first of all, if I'm at a particular node, how do I go randomly to one of the neighbors of these nodes, right? Do you see how we can do that in Python? So forget about the exact syntax of the code so that we can always pull out from Stack Overflow or some other website, right? The idea here is, let's say I want some. So first of all, you'll have to choose some random node on the graph. Assume that the node is given to you, the starting node. Now you want to look at all of its neighbors and select one of that at random and jump to that particular node. How do you do that? So first of all, I should know how to get a list of all the neighbors of a given node. Once I have the list of all the neighbors for a given node, I need to choose one of them, right, randomly. So you can just Google for it. So in Network X, how do I get a list of the neighbors of a particular node? And I'm sure in like first or the second link itself will get your answer. And after that, what you have to do is to use the function random.choice. So programming for me really it's just a calculator. once you know what you have to do exactly, you can just Google for it and you'll find the code. So gone are the days when we have to cram the syntax and we have to remember the things, because Python itself is changing so fast and we don't know, maybe tomorrow some other language will come which will sort of deprecate Python also. So we don't know when we'll shift from one programming language to other. So today it has all become about, you should know what you want to do, you should know the algorithm and just search for it step by step on Google. Right. So yeah, so I understand that before coding a specific social network related problem, you should have like practiced some Python. Right? You should have an idea of basic data types in Python in this dictionary. So what we have used in the course are just some basics. And yes, regarding that problem that, so back in 2018, I think we used Python version 2. So now I think it's version 3 going on, and there are a whole lot of functions which do not work. So that, I think that's one of the questions in our spreadsheet also. So the solution to that is either you figure out the newer version of that function on your own. If you can't do that, you can deprecate the version of Python on your system and work with Python too. Then all of those codes will work. Right. But yes, so our objective should always be that we should be able to write our own code. And so honestly, for me, it is easier for me to write my own new code rather than understanding someone else's code and reproducing that. So are all of you computer science students, or are you from like different fields? It will be good to know about some of my students, especially.
Ma'am, mine is electronics and computer engineering from VIT Chennai.
Okay, okay. So currently in which year, Nilesh?
Third year, ma'am.
Third year. That's great. So you are taking it up as an elective course?
Yes, ma'am. Like for the university elective completion. Actually, I took the course Joy of Computing of Sudarshan sir previous semester, and
Okay.
I actually did well, and I also liked his teaching way of teaching. So I took this course.
Oh, that's great. Then I think you'll have a decent idea, right, into Python. And we also used, I think, some of Network X library in Joy of Computing also.
Yeah, actually, I like it's been I guess we're completed week till 6 weeks, right? So, ma'am, like all the weeks, I like the way we were able to compare the topics with the normal lifestyle, and like that way of teaching like of your sensors, that also I liked in Joy of Computing also, like the way he was able to like what to say, model the problem on the basis of the real example.
Yeah, that's correct. I would say that Joy of Computing is one such course, even if you, I mean, that's my personal opinion. I'm not speaking it on YouTube, but even if you look at websites like EDX and Coursera, I would say that even I find Joy of Computing much, much better than those. It's like really nicely done. So social networks was the first course which we did for NPTEL, and I think Joy of Computing is one of the best playlists that we have here. Okay, what about others? Abhilaksha, Farheen, Satish.
My background is of CSE, but I am also doing data science and application from IIT Madras. So in there, it is in the list of elective course, social networking. And also Sudarshan sir's way of teaching is also a reason to join this course.
Okay. So we don't have like, a lot of people in live chat, so I think we people can go on and discuss till whenever you want to do. So we can discuss about some ideas or some technicalities from the course, or maybe some of the projects if you are planning to do in complex networks or social network analysis. So exam related questions will be answered on the discussion forum, right? And I think as per my knowledge, we don't have a programming exam for the final, but still, please once confirm it from there. So most of the questions will be MCQs based on the technical content that have been told in the course. All right. Any other question? Okay, Farheen says no.
So what are the research topics in this area, ma'am?
So I have majorly done my research on influence propagation in social networks. So I actually started off in my first year of my PhD. I started off with this area on virality, and my whole focus was how do things become viral on internet. And when I started looking more and more into this, so my idea became, so I can put it like this. So let's say I'm the CEO of a company, or let's say you are the CEO of a company, and you want to advertise some product, right? So nowadays, no one, very few people use those billboard techniques. So most of the people use social media for advertisement. But then let's say there's a network of people, right? So you're going to advertise on probably Facebook, Twitter, or maybe it can be a small personalized network of people in an organization. So, and you have, let's say, some free samples which you can give out to a few people in the beginning to advertise your product. Then which are these people that you should pick? And let's say in a classroom there is an information which I quickly want to spread among the students, assuming I have the friendship network of these students. Which are the students which I should initially pick? So that actually has a huge impact on information diffusion. So initially people, there were like certain research articles which said that it's all in the content, something which is more novel or probably more funny, more controversial, something which evokes emotions go viral. But in 2012, there was this guy, YouTube Trends Manager, forgot his name, Jimmy Kimmel. So he gave a TED talk on how videos go viral, and he has some really nice stuff to show there. So he actually showed a video which is called Double Rainbow Video. It went viral on YouTube. And he highlighted the fact that the video itself didn't have a whole lot of viral content. It became viral because it was tweeted by Jimmy Kimmel, who is a popular TV host. So from there comes the idea of these influential people. So even if your idea is very good, if you tell it to wrong people, it will not become viral. And maybe if your idea is not that good, but if you have the right people to start with, it can make it smart. So that's sort of an intuition of my research. So if we have a friendship network, how do you figure out the most influential people? And the definition of influence, it can change from situation to situation. So as an example, if it's in Google PageRank, the situation of influence is slightly different. In my case, it is if it's from the perspective of information diffusion, which are the people who you should pick. My idea was actually again in 2013 there was a research which was done so these people came up with a new centrality measure which is called core net centrality, and they said that once you figure out the core of a network, those are the most influential people, and you can advertise your product to them to get your idea viral. But then there were other pieces of research which would say that these people who are in the core, they are the most famous people, public celebrities. So you actually have to give them a whole lot of money to get your to make your mark. Basically, for them to share your information. Then how do you do it? So I've been working on that particular part. So one of my research is figuring out some people which are called pseudo cores. Pseudo cores means they'll give boost to your information, and reaching them will also not be as difficult as reaching the core people. I would say most of my work is sort of theoretically inclined.
Ma'am,
Yes, Nilesh.
ma'am, like in real life, there is a example that suppose a new actor is going to make his debut. Now, before his debut, there are rarely any chances that we might know him. But let's suppose he has debuted, his movie has got hit. Now we know him, and he has become famous, right? So, like, what is there any term for this transition here? Like, because from here we can't call it a graph. There can't be a connection because uh, we know him, but it's not necessary that he might know us. But still, he got viral and he's now a famous person. And if he like, uh, let's say, if he tells about any other person, that person gets famous. That's something we were discussing in the week. But what if a person who debuted right now got a hit and has become famous? What this transition will be called in social networks?
What this transition will be called? So I'm not sure whether even a social network is playing a role or not. Right? Social network is an aspect
Ma'am,
of.
because see, ma'am, here he debuted
We don't
his
know, right? Whether
he
he's
might have acted right.
he might
He
have
might have
acted right, right?
acted right, but the thing is, there were talks about him, and then only he got famous, right?
Okay, so is it that what you're saying is he became famous because of his connections?
No, because ma'am, that's what I'm saying. Before debuting, he is an outsider, right? It might happen that he doesn't have any connection with the fans, but after his debut, he's getting famous. Many people are getting to know about him because two notions of famous. What we discussed as of now is one kind of famous is that many people know him, and second notion which we discussed in the last week was a recurring kind of that a famous person is a one who is uh,
Pointed to
referred
by.
by a famous person who is
Mhm.
referred to by a famous person. But in the first instance, ma'am, why earlier nobody knows him, but if now people are knowing him, this transition it should have some phase. There is a phase, right? So is there any term for this phase here?
Okay, actually, I don't know this term for this page, but based on what you are saying, it actually reminds me of a paper which I studied. So, for just a second, it was called something like unpredictability in the real world environment. So again, it was a work by the prominent researchers in our field, and they actually took a very nice view on how things become popular. So let's, even if you talk about any actor or let's say any scientist or a book or a music, so what kind of music becomes popular? So they have done an online experiment for this. So you might remember of. So they say that what becomes popular in the world, what becomes a hit, it's very unpredictable. So the idea is, let's say, there are certain books or certain music, and there is a one particular music which people started liking a whole lot, or in the initial days, if in the initial days people like something more, then all the other people will start following him. So it's also called conformity or herding behavior. And the paper showed that if we had like multiple parallel worlds, then which particular actor is famous today, in that parallel world it would have been some other actor. So people make their decisions as to whom to follow by already looking at who is becoming popular. Right? It is same as what happens in this preferential attachment model. How do you know which node will become popular and will get a whole lot of friends? So with the time, yes, a node which has become popular, it gains more popularity. But in the very beginning, it is just something which is a coincidence, right, or a luck factor. So that is one thing to it. So predicting what will become famous is sort of quite difficult, because there is this rich gets richer phenomenon happening there. So if you, let's say there is a position which, let's say there are certain elections, and if you are able to manage a whole lot of votes in the beginning and people know about it, then they become influenced and more people vote for you. So this is one thing which comes in my mind. And another thing is which I can relate it to. So if you look at all these four people who are like so much popular, so is there a way you can alter this network? So is there a way that I can change my connections and form a new code in the network? So can one change the structure of the network to suit his or her needs? I'm not sure how much that answers your question, but yes, I think it is something which should be researched. So we don't. So social network analysis, as such, it is not a very classical subject where things are very properly defined and everything has a jargon to it. People write research papers and they come up with their own jargons. So as such, I can't comment on whether this transition it has a name associated with it or not. Right, but again, that's a good question. So, if someone makes his mark, is it like entirely because of his or her quality, or is it because some connections are changing in the network and connections are changing in such a way that the person becomes famous? Right, so both the things can happen. Actually, both the things
Yes,
happen in both.
yes, ma'am, because it's something fascinating because it may happen that a person has some connections and a person doesn't have any connection. But how they both are ending up at the same place, or it might happen that the person having connections is not much famous than the one who doesn't have any earlier connections. So how this thing is gonna turn out, that's something
It's a
which is
very real worldly thing, you see. Sometimes we don't know how people become so much famous. Some people have connections,
yes, ma'am. And
have talent.
taking example of other two more examples which I had, like it may happen that like we know science like you know ma'am, movies are released every month, but a discovery in science, it's like a once in a blue moon kind of thing. In a span of 1 or 2 years, it might happen that there is one major discovery in science, but still that discovery doesn't get famous. But a movie which is gonna release in the next month, you know that a same story kind of movie will release in 2 3 months again, but still the hype for that movie is much real and the discovery is not getting much famous. And the second example, like when talking about the Nobel Prizes, when there is a Nobel Prize, we are much happy to know about the scientist who got the prize, but we are not much interested in knowing for what discovery he got the Nobel Prize.
Yes, so I think here is where there's like a slight shift from. So both of these are actually connected, but then again, social networks and sociology, right? How humans behave, what do they find interesting? It can actually be quite a big debate. So Abhilakshya says payoffs associated with movies is very high, but yeah, it's actually a a relevant thing, and I feel that in the Indian context probably it is more prominent. So it can also be a society-based question. I'm not sure how much related it would be exactly to social networks, but I think there are a whole lot of factors for why it happens this way. Although I think things are changing a bit these days, again, because of the prominence of social media. Um, mm, but yes, movies are made interesting. So we as professors should make our lectures so interesting. So maybe the onus is on us. So I remember Sudarshan speaking about this one. So initially, you see, so all these movies which we see, this entire big Bollywood club. So these used to be people, right, who would do some small acts in some people, right, who would what do we call that, stage drama, right? Initially, there were no cameras or things like that. So if you look at some maybe actors not of our time, but maybe our parents and their parents, they were not very rich, right? And they would have some hard earned money, but then with the time cameras came, they started telecasting it. All these people, they moved to Mumbai, and uh, things changed. So similar things should also happen with academia. Okay, slightly drifted away. So we have 10 more minutes. Any questions? Okay, which particular idea in the course did you like the most? Maybe everyone can tell us. So what was the most interesting part of the course? Till now, so I understand that not all the weeks have been completed.
Ma'am, all the topics in itself were very enthusiastic. Like all had a real life touch in them. But I guess the one which I liked the most was that stability in a triangle one. Where we had to make a actually that was why I liked it because that's not something in terms of war, so talked in terms of war, but when we talk in terms of college itself, there are many times we have to look about it because it may happen that we think of taking a friendship with a person, but later on it might happen that the things go another way. So we yeah, we can't say friendship can be a calculated one. In both things are different, but yes, it gives you in terms of when you try to study your own friendship in a longer run, it might give you an analysis of like if you would have taken that turn on that friendship, it might be something else, might be the stability of your friendship might have been something else. So that part was something which I liked the most, but yes, other parts were in it themselves were great as well.
It's a very common life thing, right? A husband code between wife and his mother is also sort of a similar thing. Right? And yeah, so all these things do happen in the real world. So if I go back to my BTech, I wasn't a great student, but then in second or third year, I actually befriended one of the toppers, and actually my GPA increased. So these things are actually real, right? If we go back and look in our life, we can see some of these things happening. Okay, others. No, nothing. You can type in the chat window. How to make projects is Abhilaksha. Abhilaksha, to work on projects, you should like figure out one topic in which you are interested in, right? So most of the projects which we work on, they are research projects, and generally the thing is if you are studying a specific idea in the course or maybe a blog or a research paper, then you get more ideas and you can work on them. Right? There is no I would say a predefined recipe to create projects. It's just about being interested in an idea and looking at what people have done previously and then figuring out what new you can contribute there. So as an example, maybe I can discuss a few ideas which I have been working on. So one is definitely to figure out who are these influential people. And since reaching these influential people is difficult, if you can do some sort of a search on this network to reach these people through your friends' friends, right? You might remember 6 degrees of separation. So if you directly reach someone who is highly popular, good chance they won't hear to you. So can you pave a path in the network, right? Something like the Milgram's experiment and use that in the context of influence spreading in a network. You might remember community detection. So that's a very, very active research area. So can you come up with a better community detection algorithm is one thing. And a lot of work has already been done there. So one of the problems which I am working on is, can you do sort of a localized community prediction? So by localized, I mean, if I give you 2 people in the network, so without actually applying any community detection algorithm because they are costly, they require the whole network, and they also take a whole lot of time, right? If you look at any community detection algorithm, so by using less space and less time, and I don't have the entire network as well, so can you make a prediction whether both of these nodes they are in the same community or not? Other research I've been working on is again the friendship network of students. It's still ongoing. So it's a work under progress, so I can't really a lot about it. But yes, what we are doing is to also capture the academic relationships between the students. So one part of it is friendship networks with whom you are friends, but what is also generally observed is in terms of friendships, it's a different network, but if you look at the academic associations between students, that might be different. So can you study academic associations between the students, how it affects their GPA, and based on that, can you suggest good academic associations to people so that they can increase their GPA? Right? Generally, instructors do that in a class. Our teachers used to do that. If someone doesn't study well, they'll ask them to come on the first bench and sit with a topper. I don't know how much that helps, but can we do it in a more scientific and technical way and do more study on that? How much of a difference does that make? And how you can fine tune these connections so that the academic results of everyone sort of become good, right? So one of the things how researchers put is like, so if you look at the people, right, who are not connected, it's just a crowd. But if you look at any network where people are sort of connections, it becomes a mega organism. So take the analogy of, let's say, graphite and diamond. They are the same thing. Both of them are just carbon atoms. You arrange them one way, it becomes completely different. Arrange it another way, it has completely different property. So that happens with human networks as well. So again, there are studies like, can you look at the structure of an organization? So can you look at the structure of an organization and comment something on how successful it will be? And people have done research on that. So they have correlated some network metrics with the success of an organization. So if, let's say, some people are working on a research project, can you look at their friendship connections and predict how well will their research go? Okay.
Ma'am, one last question.
Yes.
Like, besides the video lectures per week, are there any other books or any other website which you will refer? Like, it might happen that sometimes for the assignments I have to like go through the web, but when I go through websites, it becomes all the more complicated because the terms which we are using, they have a different meaning, and those meanings are coming up more than the social network one which I am looking for.
Okay, so the one book which we are like predominantly referring for this course is what you can see in the chat window. It's called Networks, Crowds and Markets. It's by John Kleinberg, right? So from a perspective of a technical reading into the jargons and the things which we are using, there are also some very nice popular science versions released on network science books. So I'll also give you a few of them. They are very interested reads based on social networks. So one is by again Nicholas Christakis I was referring to, and the book name is Connected. There is yet another book called Linked by Albert Barabasi. So the later two are sort of popular science reads, but the one which we have been using for course is the first one, Networks, Crowds and Markets. You will find exactly the same topics which are being discussed in the course in this book. And Networks, Crowds and Markets, it's freely available on Google. Other two, I'm not sure.
Okay, thank you.
You'll find a PDF version. Okay, all right. So, Monojit says, what do you think of the current lab research social network condition?
So, Monoji, so as I stated, right, so the current situation is people are working more on social networks in relation with the machine learning, right? So, I think that is the latest thing which is being done. So, there are some parts to it. So, there are some people who connect social networks with sociology completely. So, that's like a different direction. There are other people who look at it completely from a data analysis perspective, and from that perspective, I think that machine learning with graphs and graph neural networks is something we can look at. So those are the two research directions which come in my mind. But it's a highly applied course. So network science is actually one such field where people from all the different domains have participated in, and one of the, trust me, like one of the domains from where people have participated here are actually physicists. All right, Nilesh, all right. Rather, all of us will take a leave in a while, right? Okay, where in my research do I employ complex networks and network analysis methods? Okay, so in my research, so as I told you, right, initially I was working on finding out influential people. Then I also worked with NPTEL office for some time. So unfortunately, I didn't spend much time there. But during when the time I was there, so my objective was to look at these discussion forums. So each of the course has discussion forums, right? So I was thinking that if we have data of all the discussions forums and how people are participating in that discussion forum, not just about NPTEL, but any other massive open online course, any other MOOC, can you look at how people are discussing on this discussion forum? Can you study that network? Who is talking to whom? Create a network there, and from there, can you predict how well will a student do in the course? Are there students who do not participate in discussion forum and still do well? Or can we correlate how people participate in discussion forum to their performance in the course? So if we can make such kind of correlations, we can actually help people tell what will, we can sort of suggest people what they can do to increase their performance in the course. That was about MOOCs. And yes, in my research, then I was studying the corporate network, right? As I told you. So currently I'm more into machine learning with graphs and graph neural networks, and I'm also learning with time. How much can shadow profiles or bots influence the accuracy in detecting influential people in social networks if database of shadow profiles or bots is not available? Shadow profiles for bots influence the. Okay, so from the perspective of the work which I have done, so I can give you a few examples here, though I'm not very sure how much they relate to the shadow profile, but yes, I can sort of take it. I think like if someone wants to do some changes, right? Someone wants to fake being influential. So whenever we talk about the idea of influence, so figure out who is most influential in a network, take it from the perspective of Google PageRank. Right, the search engine with which Google became popular. If I give you a network of the web pages, right, you know already what that network is, this network of hyperlinks. How do you tell which web page is the most important? And one can simply say the one which has most hyperlinks, the highest in degree, let's say the one to the one page to whom all the other pages are wrapping is probably the most important. But you see, if we go by that definition, then well, yes, one can create a whole lot of fake accounts, right? Write a code for this, create a whole lot of Twitter accounts, or let's say create a whole lot of websites and refer to their own website, right? So that's why we don't use such kind of an approach. In degree cannot be trusted because people can fake in degree. So from there is the idea of this Google PageRank came. So the idea is again, right, as you know, so you are important if you are followed by important people. So that sort of removes that fakeness from it. So now no one can fake it, because if you are creating your own profiles to follow your old profile, those profiles are not important. Monaji, I didn't quite get the question. So, if you want to qualitatively describe and analyze social media debates that happened in the past, is the observation, ma'am. Okay, social media. So, see, what we are studying here is sort of slightly different than social media. So, our objective here is basically graph theoretical foundation of social networks. And as I said, it's just not the social network, it's any other complex network also. So look at the ecological network. Can you figure out which is the most important species? If that species become extinct, it will have an immediate effect on your ecological network. So we look at it more from a scientific angle, right? Rather than what's happening in debates and news. I think that's how I put it. So especially the kind of work that I do, that's like more research oriented. But well, yes. So in a sense, the debates which go on, they connect to research. I saw all this hype about privacy and anonymity of network. Right? So no one can just release the network of Facebook like that. You have to maintain the privacy of people. So people release anonymized networks. So again, there are a whole lot of different directions of research to address this issue. And one of the directions in which one of my friends was working in is to, let's say, 10 of us get together and we want to find our average salary, but no one wants to reveal that salary, their salary, right, to anyone else. Is that even possible? What do you think? So let's say all of us get together and we want to find out what's our average salary. We don't need the help of any external person, but none of us is willing to reveal our salary to each other. Can we do that? It's a privacy question, right? Similar to the debates that happen in social media. So I want to keep my data private, but then how do we go about it? So there are protocols to do this. They are called secure multi-party computation. Look at that. A bunch of people can actually get together and they can create their social network without explicitly knowing who is friends with whom. You see, just like how this friendship network is so important, the animosity network is also important. Can you? So collecting friendship network is quite easy, right? Even in a college setting, you can go on people and ask them about their friends. They'll happily tell it to you. But go and ask someone about their enemies. I don't think anyone will give that data. So let's say we are the part of an organization, and how this enemy network looks might have a great deal of impact on the success of the organization. But how do you make this network if nobody is willing to reveal their enemies? Right. So again, there are research protocols to do that. Okay. All right. So I think we are already past time. If there are no questions, no more questions, we'll close this session. So if you have any research-based query regarding the projects or some idea which you would like to take further, always feel free to send me an email. I'm leaving my email in the chat window for those of you who are here. Right, and we can connect more. Okay, so with this, we'll end the session. Thank you everyone for joining.